Continuing on with our discussion about parallel streams internals, let's now turn our attention to the order in which the processing takes place. And this kind of comes back to what we talked about before, some things you can change and things you can't change. So we'll talk about order of processing. So the parallel streams framework allows for variability in the order in which processing takes place. So the processing of the chunks in the common fork join pool is intended to be non-deterministic. What that means is that it's up to the framework, it's up to the virtual machine, it's up to the underlying operating system scheduler and the hardware and all that good stuff to decide when the different chunks get computed and what cores they get computed on. However, interestingly enough, you, the programmer, still have control about the order in which the results come back to you. So the processing is non-deterministic, the processing order is non-deterministic, but the results of that processing can be deterministic. And that may seem a little bit weird at first, but when we talk about it, it'll make more sense. So as we talked about before, the chunks are processed in a non-deterministic way. That's by design. And what that means is if you were to instrument your code, for example, if you were to use peak operations and you were to print out the thread ID of the intermediate operations that are being run on the different threads in the pool, you would find that from run to run, you could end up with very different orderings in which those chunks are processed by cores in the multi-core processor. And that's okay. That's actually designed to be that way. You have little or no control over this. And the reason for this is to give the underlying infrastructure plenty of leeway in terms of how it wants to optimize the computations. So if the underlying fork join pool can do some work stealing in a way to keep the processor cores humming along at full tilt, then it will do that. And it may work differently each time because the computations may run at different rates, at different for different runs, for different data. And we don't want to overly constrain the way in which the fork join pool works. Remember that the fork join pool uses this very clever thing called work stealing, where if a thread in the worker thread pool in the fork join pool runs out of its own work to do, rather than going to sleep, it will kind of compulsively and neurotically look around to find some other thread with work that it doesn't have time enough to do, and it'll steal that work and it'll keep processing it. So the goal is to keep everything as busy as we can. Other layers, things like the virtual machine in terms of, say, things like just-in-time compile optimizations, those may occur at different points during the computation based on dynamic analysis of hotspots in the code. And so that may be different. The hardware may have different ways of doing scheduling and priorities and so on and so forth. So the goal here is to be as flexible as possible and let the lower layers have discretion over the order in which things run. And that's a good thing. So as we talked about, work stealing is a key way of being able to enable higher utilization, but it leads to inherent non-determinism. And we'll talk more about why that is later. So the key point of this set of slides is just to alert you to the fact that the processing order may be non-deterministic, but as we'll see in the next set of slides, the order in which the results are going to be provided to the programmer, typically in the form of things like reduction operations, terminal operations, like collect, you can have control over that. So we'll talk about that in the next slide set.